Hello dear students. Today in this video I am going to discuss the second part of the chapter metals and nonmetals. That is the topic today we are going to discuss, that one is chemical properties of metals and nonmetals. So before getting into the chemical properties in detail, let's recall a term, that is litmus paper. Litmus paper is used to check the given substances whether acidic or basics. That is, we have to remember. So let's see how litmus paper will work for the checking of the given substances acidic or basic. In case of the product formed by the reaction, while we studying the chemical properties, we need to check those product or substance whether it is acidic or basic. Dear students, here I have taken a small amount of nitric acid in a beaker, and red litmus paper and blue litmus paper, both I have taken. Okay, you can see here. Now I am going to dip this both the lead and blue litmus paper in this acid solution. So let's see what will be happen. You can observe that red litmus paper stay as a red and blue litmus paper change into red. Clear? That means litmus paper is used to check the acidity or basicity of the substance. Now similarly, if you dip these two litmus paper in a basic solution, the red will be changed into blue and blue will stay as a blue itself. Clear? Okay. On the basis of our observation, we can sum up the result as it is. In case of red litmus paper, if it is dipped in an acidic solution, there will not be any color change. But if it is dipped in the basic solution, then it will turn into blue. Similarly, in case of blue litmus paper, if it is dipped in acidic solution, it is turned into a red, and if it is dipped in the basic solution, there will not be any change. That means basic solution always show the color blue and acidic solution always show the color red. Now let's discuss the reactions in detail. First we are going to discuss the reaction with oxygen in case of metals. Then we will discuss in case of non-metals. So first we are going to take that in case of burning of magnesium. Burning of magnesium. Magnesium is a metal. We already discussed in case of classification of metals. Let's see what will happen if a magnesium ribbon try to burn. Dear students, we have taken a small piece of magnesium ribbon here and we are going to burn that one. Okay. So now we are going to burn this one. Okay, now you can see here the magnesium ribbon is burning with a white flame. Okay, you can see this ribbon is burning right now. Over. Now you can see some white ash here. This is the magnesium oxide. When magnesium react with oxygen, it forms magnesium oxide because burning is actually a reaction with oxygen. We observe that magnesium ribbon burns nicely and by forming a white flame. That is actually a reaction of magnesium with the oxygen present in the surroundings or in the atmosphere. That is magnesium plus oxygen gives that white powder we got, that ash is actually magnesium oxide. Magnesium oxide. That means generally we can say that metals react with the oxygen plus oxygen to form metal oxide. Metal oxide. And if we make the solution of this ash and we check the acidity and basicity of the solution by litmus paper, we will get that these metal oxides are basic in nature. We can also write this equation in terms of symbols, that is 2mg plus O2 gives 2mgO, that is magnesium react with the oxygen to give magnesium oxide. This is the chemical equation in case of the reaction of magnesium with the oxygen. That means this is the burning of the magnesium. So burning is actually a reaction of substance with the oxygen. Here we burn a metal, that is a reaction of metal with the oxygen, which gives metal oxide. Now let's see one more example in case of reaction of metals with the oxygen. Have you noticed this one? What is this? Iron. But if the iron is exposed to the atmosphere for a long time, then you can observe that the color of the iron turns to like this. This is nothing but a rusting of the iron. Rusting of iron. Rusting of iron. Here, rusting is actually a reaction of this iron or metal with the oxygen present in the atmosphere. Then what is the difference between the rusting and burning is that rusting takes place in the presence of moisture. We can write the chemical equations like iron plus oxygen gives iron oxide. Have you seen this one? What is this? This is a copper. Copper is a metal. And you can see here some green coating is there, right? This is actually rusted copper. Rusted copper. Clear? But here the rusting of copper, that reaction is little complex. It's not a simple reaction take place in case of magnesium and iron. So we can say that third we are taking, that is rusting of copper. Rusting of copper. Rusting of copper take place, that is copper Cu. This is the symbol for copper plus moisture. Moisture consists of H2O, mainly H2O plus CO2 plus O2 oxygen. So this is, we will call it as moist air. Okay, and will give copper hydroxide, CuOH twice, copper hydroxide and copper carbonate. This is copper hydroxide, and this is copper carbonate. See here, the green mixture, the green substance is a mixture of copper hydroxide and copper carbonate. Clear? So this reaction is here also, it is forming metal oxide, but not a simple metal oxide, instead of that metal hydroxide. So this reaction is little complex, but still this is also a reaction of metal with the oxygen. Clear? That is also we have to remember. And rusting is very slow process, while burning or combustion is fast process. Clear? That's all. Now let's take the case of non-metals react with the oxygen. Non-metals react with the oxygen. Let's take a burning of sulfur. Sulfur is a non-metal. Okay, so what will we get? Sulfur plus oxygen. Because burning is actually a reaction with the oxygen. What will we get? Sulfur dioxide. That is non-metal oxide. We can write in a symbolic form, that is S plus O2 gives sulfur dioxide. Two oxygen is there, because of that it is called sulfur dioxide. Okay, clear? And while burning of the sulfur, just collect the gas formed by the burning of the sulfur, and add some water to that gas and shake well so that this gas, sulfur dioxide, is mixed with the water. So we will get a solution, that is sulfur dioxide plus H2O. Okay. Then check this solution with the red litmus paper and blue litmus paper. You can observe that this solution is acidic in nature. That means the product formed so is H2SO3. H2O and SO2 reacting together to get a H2SO3. This is nothing but a sulfurous acid. Sulfurous acid. Clear? That means this sulfur dioxide is acidic in nature. Clear? So we can say that non-metals react with oxygen to form non-metallic oxide. Non-metallic oxide which are acidic in nature. While metallic oxides are basic in nature. This is the main difference you have to remember. Okay. Next is reaction with water. First, let's discuss in case of metals. Let's see the reaction of sodium metal with water. So let's discuss reaction of sodium. Reaction of sodium with water. So you can observe that in this video that small pellets of sodium drop in the water. So at the same time, it began react with the water and forms some fumes. Clear? That means it is highly reactive with the water. That means not all the metals are highly reactive with water. Some metals like sodium vigorously react with the water. So we can write the reaction like sodium plus water it forms sodium hydroxide. After checking the solution with the litmus paper, we get that is base. Okay, that means it's pakka but not basic in nature. This is actually called base. Clear? So metals plus water, generally it forms metal hydroxide, which are actually base. And during this reaction, it produces a lot of heat also. Clear? So it is very dangerous. Sodium is highly reactive, so we are not supposed to perform the activity without proper precaution. Clear? And because of this reason, sodium stored in kerosene, because sodium is highly reactive and it is vigorously reactive to the water. Because of this reason, it is stored in kerosene. Clear? Okay. And next thing we have to remember regarding that one is non-metals. In case of non-metals, they do not react with the water. Generally, they do not react with the water. They are non-reactive with the water. Okay. So now let's discuss the next section, that is reaction with acid. Generally, metals react with acid. First one is I am taking reaction of aluminium with acid. So here I have taken some amount of acid in a test tube. Now I am going to put some metal pieces to this acid. Okay, this is aluminium. So it reacts with acid and form some bubbles. You can see in the test tube. And these formed bubbles are actually hydrogen gas. We are discussing the reaction of aluminium with hydrochloric acid. Aluminium with hydrochloric acid. In case of reaction of aluminum with hydrochloric acid, we can observe that some bubbles will be formed. These bubbles indicate that presence of gases formed during the reaction. And to identify the gas formed, just bring a burning matchstick closer to the test tube so that we can observe that it produces a pop sound, which means that is burning. The produced gas is burning. That means that produced gas is hydrogen. Produced gas is hydrogen. And the substance present in the solution will be aluminium chloride. Aluminium. That means generally we can, this aluminium chloride is a salt. So generally we can say that metals react with acid. Metal react with acid to form salt and hydrogen gas. That is very important. Clear? Metals react with acid and to give salt and hydrogen gas. This is general. In case of sodium, we can say that in case of sodium plus acid, that is hydrochloric acid, HCl. Okay? Hydrochloric acid, HCl gives sodium chloride plus hydrogen, H2. So simply we can say that 2Na, sodium, Na is the symbol for sodium, plus 2HCl gives NaCl, 2NaCl, sodium chloride plus H2. This is the reaction. NaCl is the symbol for sodium chloride. So that is a salt, common salt that we are using. Clear? So this is all about a reaction of metals with the acids. And copper is a metal which do not react with the dilute hydrochloric acid even on heating. That is an exception. Okay, it only reacts with the concentrated acids. The acids, concentrated acids means the presence of the acid content will be high, or in case of dilute acid, the presence of the amount of acidic content or acid will be in the solution will be less. Clear? While in case of nonmetals, generally the nonmetals do not react with the acids, so we don't need to discuss that. Now the reaction of metals and nonmetals with base. Okay, and in case of metals react with base. For example, we can take aluminium plus sodium hydroxide. Sodium hydroxide is a base. Sodium hydroxide gives, just take some amount of sodium hydroxide in a test tube and put some pieces of aluminium. Keep for some time, same bubbles will be formed as we discussed in the case of reaction with acid. So this presence of these bubbles indicate the presence of hydrogen gas. You can check with the burning matchstick. It will produce a pop sound. That means hydrogen gas and some other substance. The reaction is not simple as the reaction with the acid. So some chemical substance will be produced. Okay, and this hydrogen gas will be formed. And in case of nonmetals, the reactions are so complex, so we are not going to discuss that one. It's not that all the reactions take place in a simple manner as we discussed in the previous case. Clear? So the reaction of nonmetals with the base are very complex reactions, so we are not going to discuss that one. Okay. Now let's discuss some metals and nonmetals present in base and acid. First column is bases. Okay, calcium hydroxide is a base. Its chemical formula is CaOH twice. The OH represents hydroxide. Clear? So here the metal present, that is calcium. Okay, and in case of sodium hydroxide, NaOH, sodium and OH is hydroxide. So here sodium is the, as in case of calcium, sodium is the metal here. And in case of magnesium hydroxide, magnesium will be the metal, magnesium. MgOH twice. This is the chemical formula, chemical symbol. Lithium hydroxide LiOH. That is here lithium is the metal, lithium. And in case of potassium hydroxide, it's not a hydride, it's hydroxide, okay? Hydroxide. So here potassium is the, and in case of hydrochloric acid, chemical formula is HCl, hydrogen and chlorine. So hydrogen is common, so chlorine is the non-metal here, chlorine. And in case of nitric acid, HNO3, HNO3. So here nitrogen as well as oxygen. Hydrogen is also a non-metal, but hydrogen is essential for all the acids. So hydrogen is not a specific one, okay? So nitrogen is the non-metal present here, nitrogen and oxygen also. And here sulfuric acid. Sulfuric acid chemical formula is H2SO4. Hydrogen, sulfur and oxygen. So sulfur is the main content. And acetic acid. Acetic acid is the main content in vinegar. So its chemical formula is CH3COOH. So carbon is the main compound. Carbon is the non-metal. Carbon. And in case of sulfurous acid, that is H2SO3. Remember the difference between sulfuric acid and sulfurous acid. Sulfurous acid we already discussed, that is H2SO3. Only 3 oxygen. Here it is 4 oxygen. Clear? So that is different. Here say sulfur is the main non-metal. Clear? Oxygen is also non-metal. Clear? Hydrogen, you can see that hydrogen is common in all the acid. Clear? That is very important. Next topic we are going to discuss, that one is displacement reaction. The displacement reaction is a reaction in which a more reactive element displaces a less reactive element from its compound. That is called displacement reaction. That is, we can see here AB is a compound. A is one element and B is another element. So AB is a compound, a group. And when C comes to the AB and C replace A and combine 2 with B. That means here AB is the and C comes to AB and C replace A. C removes A and combine with C. B. That means C is more reactive metal than A. So this is only possible. C should be more reactive than A. That is, this types of reaction is called displacement reaction. One element is displacing another element from its compound. That means C displaced A from AB and it combines with B to form compound. Then A become independent. Clear? Okay. This types of reaction is called the displacement reaction. Let's discuss the activity 4.8 to understand displacement reaction in detail. We have taken 4 beaker, okay, and label it as A, B, C, D, E. Then, taking first beaker, that we have taken copper sulfate and zinc. So this blue color solution is copper sulfate, okay. This blue color solution is copper sulfate and put some zinc pellets, okay. In the next beaker we have taken again copper sulfate and iron, okay. Color is again blue color, so the color of blue, solution will be, as it is copper sulfate, its color will be blue. And we have put some iron nails. In the third beaker, the solution is colorless. It is because that solution is the main solvent is the main component is zinc sulfate, okay. And zinc sulfate, then we add some copper filings. And the fourth one, that is D, is iron sulfate. Okay, this is the color of iron sulfate, and we add again some copper filings. And in the fifth one again, that is colorless, that means it is zinc sulfate, and I added some iron filings. So this is the combinations we have taken. Okay, this blue color represents copper sulfate, and this in beaker C and D, the main component is zinc sulfate, and the D, that is iron sulfate. And these are the substance we added to this solution. Okay, and keep for some time. Then after some time we can observe that the color of the solution of some beakers will be changed. Okay, after reaction you can see this one. What happened here actually? This is become colorless. Okay, and this is become a light green color. And here you can see what happened. Here in these three beakers, in A, B and E, D, in these three beakers no color change. That means no reaction take place. No reaction in this. But in first A and B reaction take place, but in C, D and E no reaction. So let's sum up the reaction in beaker A. That is, what was in beaker A? Copper sulfate and zinc. That was we kept. Copper sulfate plus zinc. And its color is changed because blue color is almost get vanished. Not completely, because still some amount of copper sulfate is present. Because of that, it's not completely colorless. Still a small bluishness is there in the solution. Clear? It is because this zinc is displaced copper and formed zinc sulfate. Zinc sulfate plus copper is displaced. Clear? That is what we have to remember. We know that zinc sulfate is colorless. Because of that, its color is getting, this solution is become colorless slowly. And in case of second one, what we can hear, green color, yellowish, a small green, yellowish green color is there. What is the meaning is that in beaker A, we can observe that what was the substance we added here? Copper sulfate, and I am writing the chemical formula of copper sulfate plus iron. Okay, copper sulfate plus iron. Then what happened? Here it was blue. The color of solution of copper sulfate, the color of copper sulfate solution is blue in color, while it is become yellowish green. It is because some part of this copper sulfate solution is changed into iron sulfate. That means this is actually an yellowish in color, yellowish brown in color. So yellowish and this blue color mixing, it is getting a yellowish green color. Clear? That means copper sulfate and this iron is displaced copper from the sulfate. So we got a iron sulfate and iron sulfate plus copper. Clear? Because of that. And what happened in these three beakers? In these three beakers, it was in the beaker C, we have taken zinc sulfate and copper. Is there any reaction? No reaction. Okay. And in case of beaker D, we have taken iron sulfate and copper. Iron sulfate and Fe. Iron sulfate and copper. No reaction still. No reaction. And in E also we have taken zinc sulfate and iron. We have no reaction. Why this? Why is in some beakers reaction take place and why in some it is not? It is because here zinc is displaced copper. Zinc displaced copper sulfate and zinc comes in the place of copper and copper is separated. Similarly, here iron is displaced copper and iron comes with the in the place of copper and copper is separated. That means zinc is displaced copper, iron is displaced copper. That means zinc and iron both are reactive than copper. So copper is become less reactive. Now see here, copper is less reactive, so it cannot displace zinc because of that no reaction. Here also copper is less reactive than iron, so it cannot displace iron from the iron sulfate. So no reaction will take place. Now see here why. Iron also cannot displace zinc from its solution. That means iron is less reactive than zinc. So we can say that in case of reactivity, copper is least reactive than iron than zinc. So zinc is the most reactive among these three elements. Clear? Copper is less reactive than zinc and iron. Both are more reactive than copper. Because of that, both are able to displace copper from its solution. While zinc is more reactive than iron. Because of that, iron cannot displace zinc from its solution. This is the conclusion we are getting from the displacement reaction. This is all about the second part of this chapter. And regarding the uses of metals and non-metals, you can refer the page number 51 so that you will get a clear idea about that one. So I'm going to conclude this chapter with this video. In the next video, I will come with another chapter. So that's all for today. Thanks for watching.